Yeah, thank you. Uh, so coming to this, mm, so where we have stopped, we were looking into HTTP and HTTP post and get methods. Right. Now, in the morning we have seen some kind of PIR sensor. Uh, Instead, we shall just look into some kind of temperature sensor or something. Where currently I have just DHT22 available with me. This like some other sensors are in the office, and due to lockdown, I couldn't manage to get those things. Right. So DHT22 is manufactured. Right. There are libraries provided by Adafruit, um, and this what we shall do is we shall write some code. First, we need to connect to this server, sorry, to Raspberry Pi. So what I will do is instead, I'll do it again. Okay. Uh, can everyone see my screen?
Not yet, sir. Yes, sir. It is visible now.
So, so here you can observe that. So here we go with the connecting to Raspberry Pi. So what was the server's details? Okay, that session is gone. Pi and three, so here I have two different sessions. So one is Raspberry Pi and another one is my cloud server, right? This right side one is my cloud server and this left side one is my Raspberry Pi, right? So into this left side, say Raspberry Pi, what I have is I need to first read sensors information, right? So in this, what first I'll be doing is I'll just import few libraries. So first I'll create, I'll go to desktop. Here I don't have anything. So what I'll do is here and go to MK plus. So what I'll do is here I'll do it in the non-desktop itself. Nano. This is DHT22 sensor. Give that name DHT22.5. Right. So in this, if you just observe, so first thing that we'll be importing is import and also libraries. then import request sensor, or you can say file name is equal to which pin I'm connecting. Give some pin number. So this pin numbering, here we just can't use it as port pin number. We need to use Broadcom pin number. I'll say I'll connect it to pin number 4. Thereafter, uh, I'll say this is H is humidity, comma T is temperature, where so this whatever sensor we are discussing, that is uh, a single wire protocol. So I'll show it in detail. How exactly this is. Then there we should input pin X. So here, if you can say observe, so here if you observe, uh, just this is the DHT sensor, which is having 3 pins similar to your PIR sensor. So this PIR sensor will just give a pulse, high low, with whenever there is a motion. So this DHT as a humidity and temperature sensor, which uh, works with a single wire protocol. Means a request is sent onto the same wire, and the response will also be onto the same wire, right? So I have connected this to the same 7 pin number where I have connected this uh, PIR module, right? Now the connection is already done, so there is nothing to observe in the camera because the temperature is automatically varying as per the atmosphere. Right. Okay, just get this, get back to this code. Right. So I'll just first check Python DHT 2.5. It keeps on trying. So once the data is received, and then you give the response. So there you can observe the humidity is the first parameter which is printing. It is 50% humidity in the atmosphere as the temperature is high and the temperature is 33 degrees Celsius. Right. So it has good precision. You can see. Uh, so similarly, there are different models available, DSG 11 or something, which is bit less precise. Right. So if I again run this same, uh, we get the response. So it keeps on trying. Whenever there is any communication error, it will be repeating the activity. The humidity getting reduced. Right. So if I just place this temperature sensor onto, okay, so the Raspberry Pi itself is got restarted. So we need to wait again until it gets restarted, and we need to create a connection. Just a few minutes. Type in the port IP address change. Right. This is the Raspberry Pi again, which we have started the session. Now I'll go back to uh, desktop. Here I'll see this as nano THT22. Right. So this is the library where we can get complete data into a single line. Right. So even we don't need to type these things as a different variables. Even if we are just writing it here itself, uh, right, instead of pin number, if I'm writing pin number 4, right, I don't need this. So here you can observe that is just a single line code. So again, you can observe the temperature is 33 point something. Right. So now, what all things we have done is to get the sensors information to remote location. Right. Means whenever if I'm even if I'm searching in my phone, I should be able to get the temperature, whatever logs we are writing, or the current temperature which is available, which is on the R file. Right. So what we shall do is uh, we shall send this information to the server. So before that, first we shall set up the server. Server is here. So this is your Ubuntu cloud server, which is AWS one. So what I'll do is I'll just do some modification in this HTTP server, right? So temporarily we shall keep this post aside. It does not complicate the things as we have less time, right? If we have understood this GET request, right? We shall send this information in the URL itself, right? So what we are doing is we are opening a file, we are appending the things, right? So I'll this say this file name is temperature.csv, right? So whenever it is inserting, it is going to next line, right? So it is closing it. So it keeps on updating the things. Then we shall write another class, right? This is one, I'll say, right? So here what I'll do is I'll open it in read mode, right? So it will just read the entire data. There data is equal to read. So now is reading the entire data, and giving it as a response. I will say this is save them, and this is get it log, right? Keep it small, everything, data, right? And this will be testing one, right? So I have written two different classes. One is to store the information into the object, into the file, and the second one is to read the file and give it back to user, right? So what I'll do is nano temp dot sv. I'll just create this file, right? So this file is present, right? So now nano unicorn colon add, right? The server is running. So first we shall check it with browser. This is the same thing. First one is save temp, then slash say 33, I'll say degree Celsius or 31, right? So it has received and the data is saved, right? Then if I observe into this cat temp.csv, it is storing 32, right there. So what next thing we wanted to do is get temp or get log it was, right? Internal server error. Okay. Okay. So here we have written unnecessarily a X here. Since I'm asking get log, so it is giving 32, right? So this way. Now, once again, I'll go back. Instead of 32, I'll say 35. So 35 is gone. So again, I'm saying 37. 37 is gone, right? So the same way, if I'm going back, if I'm asking for same URL, just asking for log, get log. So there you can see this log, right? So the same thing you can observe it from anywhere. If you have a mobile phone or you're connected to any in any way, any mode, so just check onto this. So here you can get the log, right? So you can check onto your browser or in your mobile phone or any possible location. Right there. Now, what the next task is, we need real-time data. What are things we are storing in here is from browser, right? Now we need to get back to our Raspberry Pi. server. So here we are back to Raspberry Pi. The way we wrote the code is on the desktop. Then so what next thing we need is request library. So in request, what we will be doing is sending HTTP request. So response equal to again say okay, right. So in this get request, I just file this. Instead of 37, so what I'll do is I will add this temperature data file, making it a string. And then we should also print whatever the response is. So the same sensors, whatever we are reading, and here you can see it has sent, and the response is okay, right? So here the server should have received the data. Uh, okay, so okay, 5 is broken. Change back to it, right? Uh, that uh, So here you can observe whatever sensor it is reading, that sensor's information is being stored onto cloud server's file, right? So once again, if I run this, right, there again you can see. So I'll try to change the temperature here, right? That's in the sensor. Again, you can run it. So you can see it is almost same. Humidity is increased. So this what all things is sensing that are stored into this file, right? So this way you can write some kind of real-time applications, right? Now we have done with this sending sensors information to server. Now we can put it in a loop. Say what I'll say, instead of just reading it once, what I will do is I'll put it in a loop, say for, or you can say while loop, while is infinite loop, means it will be running until I stop it. Print the request fonts. I will also say print fonts text also. I even put a delay of 5 seconds. Over time. Done. So this will be continuously reading the data and posting. So this is being saved. Now here if we keep observing the new temperature. So we can even pass temperature and humidity by separating it then by comma. Right. So what I'll do is again touch the sensor. So my body temperature and room temperature are almost same. Right. After 10 seconds it is hitting on, pushing into server. Yes, whatever things we have written, that can be observed onto our browser. So here is our browser. There is some kind of error in this code. Server is running in background, right? microphone. So here you can see in browser. So this way we can build any kind of application. So this whatever sensors values we are getting as a log can even be shown in a proper format. Means whenever we are pushing this to server, we can send it in proper format with its time and many more things, right? Uh, so even I was thinking to start the MQTT server, but it will be very confusing and it's complex to understand in same day. So many new things, right? So this MQTT servers activity we can postpone it for tomorrow, right? So till now, what all things we have discussed that we shall repeat it if, or you can uh, what we can say, we can have a query session or something like that. So which you would prefer? Should I repeat the activities which we have done, or say individual query is preferred? Yes, no, or is everyone just keeping their phones or desktop aside? So at least someone respond to this. Shall I repeat the activities which I have done, or do you have any queries which I can solve? So please let me know what we can do. Yes, no. Is there anyone active? My voice audible to anyone? Yes, no. Presentation is not visible. Actually, I'm presenting. So is it visible now? Okay. So just let me know. At least two are active. So shall I repeat the things, or do you have any queries which you can solve? Hmm? So here is the server already running in background, continuously pushing, and this is the temperature values which are continuously varying. Right. Output is pushing it is into log, and here we can also observe it into our browser. Right. The same log can be observed by you also. Right. I'll share the URL. Already I have shared. So actually today's content is done. So we don't have anything like we have much content, but that will be of no use if I continue the session. So the MQTT server, which I was planning, which I will be conducting it tomorrow in the morning session. Uh, that's it. So for today's session, this was the content. If you have any queries, please ask.
Participants are requested to ask queries, if any.
So if there are no queries, we can stop the session. It's not an issue. So, ma'am, shall we stop the session?
Yes, sir.
Yeah. Thank you, ma'am. So thank you all. So tomorrow we'll be starting again at 10 a.m. I think. So there we can continue with our MQTT server, where we can control some remote hardware from our mobile phone or something. Thank you all.
Okay. Thank you very much, sir.
Yeah.
Tomorrow's session will begin at 10 a.m. and within a few minutes we'll today there is no any assignment. So tomorrow assignment will be posted on WhatsApp group. Okay. So thank you.
Thank you, ma'am.